Okay, Assalamualaikum everyone, and a very good day. Okay, so for today's section, I'm going to explain on solving the first ODE, okay, using linear method, or we call it with integrating factor. Okay, so I'm going to show to you the slides. Okay, so the topics on the solving first linear ODE, okay, is on first ebook, page number 4, 5, 457. Okay, so in the first ebook. Okay, so I'm going to explain and describe briefly the steps, okay, how we can apply the integrating factor or linear method for solving first linear ODE. Okay. Okay, so there is a different form for the first ODE that we call linear ODE. Okay, so linear ODE that is having different form here. Okay, so the one that I show, dy dx plus py equal to q. So when we have this kind of linear first ODE, so it's not we not be able to apply separable variable. Okay, so that is why there is another method that we can use to solve that we call as linear method or integrating factor. Okay, means that whenever we have linear ODE, then we can use integrating factor for finding the solution for first ODE. Okay, so roughly this is the step. First one, if the first ODE is not in the linear ODE, then we make it into this form. Okay, so like this one. So any ODE that is not in the linear, but it can be transformable. So means that we can transform the original equation to this one. dy dx plus py equal to q. Okay. Okay, so after we transform into dy dx plus py equal to q, then we need to apply the integrating factor. Okay, so what is p and q means? P and q is a function in terms of x. Okay, it can be a constant also. Okay, but when there is a function together with y, then it becomes py. So it belongs to py. Then the other one that is not without y will be written or expressed on the right hand side of the equation. Okay, so this is very important. So before we apply integrating factor, the original equation must be transformed into dy dx plus py equal to q. Okay, so then we need to determine what is p, what is q. Okay, so once we determine correctly what is the p, okay, then we find the integrative factor that we are supposed to do. So the p that we need to find out must be integrated. Okay, must be integrated that using this kind of formula. Okay, so the one in the box here is the integrating factor. Okay, so after we determine P and Q, we proceed with this form. Okay, the one in the box I show here is the integrating factor that is containing E to the power of integration P dx, okay, which is on the left hand side, and then it must be multiplied with Y. Okay, so the right hand side is given here. Okay, so the label of e to the power of integration p dx. Okay, so you have to look carefully. Okay, this p dx, there's a small notation. Okay, whereby we define this as the integrating factor. Okay, so I'm going to show directly and explain the first example in problem 1. So there's a questions here. Solve this equation given the boundary condition as x0, y equal to 4. So means that we need to find the particular solution. So the equations here as the original equation is 1 over x dy dx plus 4y equal to 2. Okay, so remember that we are supposed to write down into dy over dx plus py equal to q. Okay, so this is the original, right? This is the original equation, but it's not in this form. Okay, so means that we have to modify. Okay, so to modify this one, this part must becomes 1 dy dx. So there is 1 dy dx. So means that to make it 1, so they must be multiplied with x, correct? So when we want to multiply with x, so means that everything on the left hand side and also the right hand side must be times with x. Okay, so I'm going to repeat. To make it to this form, the original equation must be multiply left hand side and right hand side with x. Okay, so when we multiply, so the original equation becomes dy over dx plus 4xy equal to 2x. So this is the correct that we have transformed. Okay, so determine what is the P. This is our P. This is our Q. Okay, so P is 4x, Q is 2x. Okay, so next to proceed is write down the integration P dx that is equal to integration 4x dx. Okay, find what is the answer for this integration. So we have 2x squared. Okay, so this is direct integration. So I hope you know how to do it. Okay, so once we determine this integration P dx, then we find out here integration P dx. This is the integrating factor. So we can write down here e to the power 2x squared. Okay. Okay, so this is just write down notations, correct? Okay, so remember that our method in the linear is this kind of formula. It must be y times e to the power p dx equal to integration e to power integration p dx times q dx. So this formulation is very important. Okay, it's very important. Okay, so we know already what is this one. It just comes here, and we also know what is this one. Okay, that we get here. Okay, so the one that we determine, this one, simplify integrating factor, we have find out the answer. Okay, put it here, just multiply on the left hand side with y. So the right hand side plug in at this part. Okay, so we can write down the equation as follow. Okay, by following the formula as shown here in the blue color, then we have y, okay, times e to the power 2x squared equal to integration e to the power 2x squared times our q comes from here. Okay, so we have times 2x dx. Okay, so this is the part that we are going to proceed on the next step. Okay, I'm going to write on the new screen again as follow. Okay, y e 2x squared equal to integration e 2x squared times 2x dx. So there's a constant here, so we can bring it in front as follow. 2 integrate e to the power 2x squared. Okay, then we have x dx. So the left hand side remain the same thing, nothing change. So we have a task that we need to do on the right hand side. Means that we need to find out the answer for this integration. Okay, so we cannot directly integrate. So means that we need to find out special methods. Okay, so this is exponential e to the power 2x squared. Let's try whether we can use substitution method to integrate. Okay, so remember that the purpose to do substitution method for integration, okay, it must be something that it is easy for us to integrate. Okay, so if we want to apply the substitution method to integrate, the one on the right hand side, let's choose u is equal to 2x squared. Okay, so du over dx is equal to 4x squared. So this method we call substitution method. Okay, so we can write down um, 1 over 4 du is equal to x dx. Okay, so we have x dx here. Okay, so x dx, okay, will be equivalent to 1 over 4 du. So everything in x and dx will be converted to u and du. Okay, so this one e to the power 2x squared becomes e to the power u. Okay, so when we use substitution method, then the part of the integration becomes integration of 1 over 4 du. Okay, so this is e to the power u. Okay, so sort it. So when we sort, it becomes like this. So this 1 over 4 combined with the constant 2, so become 2 over 4 integration of e u du. Okay, so means that something that is complicated now becomes easy for us to integrate. Okay, integration e power u, you may refer to the formula list. Okay, integrate e power x, we get e power x. Okay, then this number 2 over 4 can be simplified, which is becomes half. So here we have half e to the power of u. So okay, that is equivalent to half e to the power. So this u change back to the form in terms of x becomes 2x squared. Okay, then we have plus c. So the one on the left hand side, okay, we can write down here as y e 2x power 2. Okay, so the one in this part at this step, including the left hand side here, is the general solution. Okay, so remember that in the original questions just now, they are boundary values given x0, y equal to 4. Okay, so we need to find to substitute into the general solution. Okay, so again, let's see on the new screen. Let's follow. Okay, I'm going to write down again the general solution. Y e 2x squared. I hope you can write down the equations properly. Equal to half e power 2x squared plus constant. So this is our general solutions, right? General solution. And then the boundary values given x0, y equal to 4. So these two values we have to substitute into the general solution to find out what is the value of c. Okay, so when we say substitute, so we have here 4 e to the power 0, we get 1. Okay, so you can simplify equal to, so here half e power 0 also 1, then plus c. So in this case, c is equal to 7 over 2. Okay, so finally, don't forget to write down the final answer in terms of the particular solution. So we have y e 2x squared equal to half e 2x squared plus 7 over 2. Okay, there's no issue if you want to transform or modify e power 2x squared to the right hand side also, you can change it or you can just leave it in this form. Okay, so this is called as particular solution. Okay, now this is the original equations. Remember that the original equations given of y and t. Okay, so it's not in the form of y dy dx. So it's in terms of dy dt. Okay, but you have to adapt the changes. Okay, I'm going to show you the solution on the screen as follow. This is the original equation. T dy dt minus 5t equal to negative y. So this is equation for exercise 183. So this is question number 3. Okay. Okay, so remember that this is not the form that uh, the one that we want it. Okay, not the form. So the form that we have to transform must be dy over dt plus py equal to q. Okay, so remember that the notes that I showed to you just now is in terms of dy dx. So change it because our case now is in terms of dy dt. So dx, okay, must be changed to dt. Okay, so that's all the changes. Okay, so this is the form that we refer. See that the original equation, this original equation is not in this form. So you have to transform. There is t dy dt. So there is 1 here, correct? So there is 1. So how to make it this becomes 1? Means that all we have to divide by t. Okay, so divide by t. The left hand side and the right hand side must be divided by t. Okay, so the original equation, when we divide left hand side and right hand side divide by t, it becomes dy dt minus 5 equal to negative y over t. Okay, so we can write down here as follow. Okay, this one also you have to modify. Negative 5 bring it to the right hand side. Negative y over t must bring to the left hand side. So we have dy over dt, okay, plus 1 over ty equal to 5. Okay, so this is the same with the one in the box. So our P is 1 over T, our Q is 5. Okay, so once we determine the P, so we write down here, P dt, okay, not P dx. So P dt, integration P dt becomes 1 over T dt. So you know what is the answer? That is equal to ln T. So the integrating factor P dt, E P dt is equal to E ln T. Okay, this is can be simplified. Ln is base E. Then we have another base E. So by rules of logarithm, we can simplify to T. Okay, so this is the simplest term. Okay, so integrating factor in the simplest form in this case is equal to T. So remember these kinds of rules of logarithm. Okay, so next we proceed. Okay, so we find out already that the integrating factor P dt is equal to T. Then we refer to the formula of y e integration P dt is equal to integration e P dt times q dt. Okay, so this is our main formula for the linear method. Okay, so we find out this is equal to t, then this is also equal to t. Okay, so in our q just now, remember the one that we have transformed, our q just now is equal to 5. So we substitute. Okay, so once we substitute, we have y t equal to integration t times q is 5. Okay, then we have t dt. Okay, so integrate on the right hand side, left hand side remain the same thing. So the right hand side, this is direct integration, no special method. Okay, so we can find the answer as 5t squared over 2 plus c constant. Okay, so if you want to bring this t on the left, bring it to the right hand side, then it's equal to y equal to 5 over 2, then t squared divided by t, we have t, okay, plus c over t. Okay, so The one that I mark, you can express any one of them that is both are accepted. So the equation we call as the general solution. Okay. Okay, so the next exercise for you will be on exercise 183, all question except for question number 3 that I have discussed just now.